Good evening, everybody. Welcome to our small webinar of the 6 steps of data analysis. We are going to look at checking data integrity, which is part 2 through assessing scale reliability. My name is William O'Bannon of StatsWhisper Incorporated. Feel free to visit us on the web at www.statswhisper.com. Now, the introduction. This has just been answered, but hopefully that'll help you to remember it. Where does examining scale reliability fit into the process of data analysis? In step 2, checks of data integrity. In short, the scale must have integrity or the entire study is not credible. So if you're measuring, say, happiness, and then your scale isn't measuring happiness, then your entire study is not representing a study on happiness. So since this is the real essential check of data analysis for me, I like to do this step first in step 2. Now, reliability in statistics. Now, this will get a little clearer as we go on. So reliability describes consistency of a measure. So let's give an example. It might be a better way to show what it means. So high reliability is a measure that produces similar results under consistent conditions. For example, the classic example of a measure with high reliability is a ruler, one measuring length, not ruling a country. So the ruler, if it's measuring in inches, if it measures somebody's finger, say, in Antarctica, and the finger's 3 inches long, it measures 3 inches. And if you measure somebody's finger in another continent and their finger's 3 inches long, the ruler measures the same length, right? So it's giving you those consistent results, right, based on the same criteria, right? How long is a finger? How many inches is it, right? So in any culture, the inches would be the same thing. Now when we talk about depression, you don't even have to go in between cultures, just in between people. Many times measures of depression might not be as reliable. For example, what if we said we wanted to measure depression and we wanted to look at changes in eating patterns? So if somebody might say, hey, if somebody stops eating, well then they're depressed, because when I'm depressed, I stop eating. I don't eat as much. And then another person might say, no, that's wrong. It's the opposite. When I'm depressed, I eat more. So an indicator of depression for me is more eating. And the indicator of depression for the second person or the first person is less eating. Therefore, we might say that eating more or less is not a reliable indicator or measure of depression, right? So there are several types of reliability estimates in statistics. That we won't go into all of them because each one of them is a subject in itself. So there's inter-rater reliability, test-retest reliability, inter-method reliability, and internal consistency reliability. Now you can see by the asterisks that internal consistency is the most reported, so that's what we'll discuss here today. So if it's the most reported, it's what we should discuss first, so here we go. Internal consistency. A measure of internal consistency asks, is a single construct being measured by a set of items? Right, so it took me years to conceptualize this. So hang on, because I'm going to compress years into about 10 minutes. So here we go. Say we had a construct, and the construct was happiness. So that's what we're trying to measure, happiness. So we want to know if a series of items measures the construct of happiness. So we look at item 1, item 2, item 3. Item 1, are you happy? Answered on the scale from 1, no, through 2, 3, 4, up to 5, yes. Are you happy on a scale of 1 to 5? Okay, that item seems to measure happiness. Are you sad? On a scale of 1 to 5 again. And are you blue on a scale of 1 to 5? Now, the item should be correlated if a single construct is being measured. Right? Let's take a look at how. So, we can see right here in the first bullet, if one is happy, the responses might be correlated as 5, 1, 1. Right? So if one person is answering this scale, and they say, are you happy? And they answer 5, yes, very happy. The next item, when it says, are you sad, should be what? It should probably be around 1, right? Because if the person is at the height of happiness, they should probably not be very sad. So are you happy? 5. Are you sad? Probably 1. Right? And then you can see if 1 is happy, the responses are 5, 1, 1. Right? So item 3 should mirror item 2. Are you sad? 1 no, not if you're happy. Are you blue? 1 no, not if you're happy. Now if somebody comes along, right, bullet 2 here, and they're not happy, the responses would be what? Probably are you happy? 1 no. Are you sad? 5 yes. Are you blue? 5 yes. So these are all correlations, and these relationships between the items indicate that a single construct is being measured. Now, let's say that somebody answered, are you happy? 5 yes. Then they said, are you sad? 5 yes. Are you blue? 5 yes. Then we might say, well, this measure doesn't seem to measure anything because the items don't have a relationship. Everything is just 5. So it's not measuring happiness because the person's happy, sad, and blue at the same time. So the intercorrelations, right, inter-item correlation, called intercorrelations of the items reflect the presence or lack of the presence of internal consistency. So the stronger these correlations are, the more internal consistency, reliability, the measure is said to have. So the most common measure of internal consistency is the Cronbach's alpha. And you can see here in parentheses, I say every study, right? Because it seems like the Cronbach's alpha is in every study. And it's the most commonly used indicator of good properties of a scale. If there's nothing else reported in a paper about a scale's psychometrics or its reliability, the Cronbach's alpha will be there all by itself. Now it ranges from 0 to 1, 0 meaning no internal consistency, and 1 meaning the maximum internal consistency. And the scientific standard is that if it's equal to or greater than 0.7 on that 0 to 1 scale, then there's an acceptable level of internal consistency. A lot of people forget even what internal consistency is, but they'll years and years remember it has to be 0.7 on the Cronbach's alpha or above to be dependable. So in order to make a measure of happiness, the items are combined. You might add are you happy to are you sad to are you blue, and you add them all on up, and it'll create one number, right? A summed number, and that will be the measure of happiness, and that measure will have a Cronbach's alpha rating within it. Now, what if the Cronbach's alpha rating is below 0.7, which happens every now and then, but you really don't want that. So there's two general things you should look at right away. The first thing is consider removing items from your scale. Right? Some of the items might not be contributing, right? Might not be correlated with the other items. You want to take those out. Then you want to look at and you want to see is there a need to reverse some items? Because for a good Cronbach's alpha, all the items have to be going in the right direction. So if we want to measure happiness, all the items, a higher score on all the items has to indicate a greater presence of happiness. So we're going to go on SPSS, and picture's worth 1,000 words sort of thing. We're going to go on SPSS and show how we would remove the items or reverse the items if needed.